Assalamualaikum and a very good day I bid to all of the panels. Today I will be presenting on my final project, which is the investigation on mechanical properties of the KENAF block. So before I start, let me just briefly introduce myself. So my name is Muhammad HAKIM bin Abdul Karim, and my student ID is 2019-268-796, and also here there is my student email and also my phone number if you want to reach me, and also my supervisor is Dr. Muhammad AZIMIN bin Abdul GHANI. So in this presentation we will discuss on these four different aspects. The first one we will discuss on the project summary, the second one on the introduction, the third one is on the methodology, and the final one is on the preliminary and expected result. First, let's start on the project summary. As we know, cement building blocks are primarily used for construction. They are made from cement, water, sand, and aggregate. So the goal of the project is to use natural fibers in the blocks. These natural fiber blocks are more environmentally friendly, and also the blocks will be tested to study the difference in mechanical properties between the usual conventional and the natural fiber blocks that we are going to fabricate. So next, we move on to the introduction. As we know, common cement sand blocks typically contain 80 to 90% river sand or natural sand, and 10 to 20% cement. Built with modern construction materials, consumes natural resources and causes environmental damage. Currently, 6% of the total anthropogenic global dioxide emissions are caused by the production of the Portland cement. Nowadays, construction and cement manufacturing company are looking for ways to make their cement block more environmentally friendly and also more affordable. Other than that, generally in masonry blocks, sand is being partially substituted with waste such as industrial waste, agricultural waste, and sand from resources other than the riverbeds. However, the process of turning the aforementioned resources into fine aggregate is very expensive and also requires a lot of energy. Additionally, there is not enough supply of these industrial waste products to meet the demand for fine aggregate. Next, the natural fibers are one of the agricultural waste byproducts. Cementitious materials have been made from natural fibers, have been derived from coconut, banana, sugarcane, jute, sisal, oil palm, and also flax. Fibers added to cementitious materials increases the ductility, toughness, and also the flexibility. So next, let's take a look on the project background. So for the project background, are divided into three different parts, which is literature review, problem statement and objective, and also scope and limitation. So for the literature review, there are a few articles and books that relates to the development of natural fiber reinforced cement block. The use of natural fiber from both resources, renewable and non-renewable, such as oil palm, sisal, flax, and jute, to produce composite material, gained considerable attention in the last decade so far. Natural fibers do not display strong bonding with the cement matrix, despite the fact that they have shown better mechanical properties of cement-based material as compared to non-reinforced cement materials. KENAF plant, one of the many various kinds of natural resources, have been widely used recently and are a particularly appealing alternative because of their quick development in a variety of climatic conditions and subsequently inexpensive costs. Natural materials should receive more consideration from an environmental standpoint because they are sustainable, renewable, and also eco-friendly. Comparing plant fibers mechanical qualities to those of the most popular competing reinforced glass fiber reveals that they are much inferior. However, due to their low density, plant fibers' unique characteristic, including their property to the density ratio, strength, and stiffness, are, are equivalent to those of glass fibers. Because natural fibers have advantage over synthetic fibers, such as an abundance, non-toxicity, non-corrosiveness, cheaper cost, biodegradability, low energy production cost, and etc. Many researchers have examined many types of natural fibers as a reinforcement material in various composites. So next, let us move on to the problem statement and objective. So these are some of the problem statement. Firstly, research on natural fiber reinforced blocks such as KENAF blocks is scarce. Secondly, demand of this type of blocks is low. Other than that, the use of KENAF blocks in construction is not widespread. Other than that, lack of knowledge about the benefits and properties of KENAF block and how to use them properly contribute to the low use in various construction projects. So these are some of the objectives. Firstly, to make and fabricate KENAF fiber reinforced block. Secondly, the blocks will be tested to determine their mechanical properties. Thirdly, all the results will be recorded and analyzed for future reference. And lastly, to make an affordable and eco-friendly block. So let us move on to the methodology. So in this part, there are 4 phases, which is the first phase is the initial study that consists of literature review and gathering related information regarding the topic. The second phase is about planning phase, which we determine the size and how to fabricate the specimen and also the test that will be conducted on that specimen. The third phase involve physical development where the specimen is being prepared and also we run a quality check on the specimen to avoid any flaws of the specimen. And the final phase is on the experimental and analysis part. So in this part we are conducting the test and also we collect all the data and make analysis on the data that we have collected. Next, let's take a look on the preliminary expected result. So for the project, the experiments to be conducted on the KENAF blocks are the compressive and also the tensile test. And one of the variable to be considered is the content of KENAF fiber in the block. So this is the table on the result of compressive test on KENAF block. From the table, you can see that the average compressive strength of KENAF fiber block is 2786.68 psi. The average compressive strength of conventional cement block is around 3000 to 6000 psi. So we can say that the compressive strength of KENAF and regular cement block is similar with only a slight difference. The figure shows compressive strength of compressed earth block CEB with fibers at different percentages. From the figure, it can be seen that the compressive strength peaks at 0.2% fiber content, which is about 8 MPa. The compressive strength then decreases with the increase of fiber content. This figure then shows how changing the fiber content affects the tensile strength of CEB. It can be seen that the tensile strength of the CEB increased as the fiber content increased. This finding can be explained by the fact that tensile stresses on fibers may increase their adherence to the matrix. The fibers used in figure 2 and 3 are sisal fibers. The finding from the sisal fibers can be used to predict the outcome and result when we are experimenting using the KENAF fibers. This is because KENAF fibers and sisal fibers are from the same type of natural fibers which came from plants or vegetables. And I think that is all from me. Thank you.